Well, hi guys, here again. Today I'll be discussing partial least square structural equation modeling part 2 on how to download and use SmartPLS SEM software and write your dissertations. To use SmartPLS software, you need to visit www.smartpls.com, click the download button, select Mac or Windows, then click Yes. When the prompt asks your email, you must enter your private email address because the site will send you a license code to activate the software. It's important to use private email, not the university email, because if you finish your study, you need to reuse the software. That's why it's good to use private email. You then have the following three options. Number one is free trial version for 30 days, free. Number two is paid academic subscription for $235 annually. Number three is free student version of the software. You need to select number three, the student version, which is free and has no expiration date. No expire. The installation process is straightforward. You just need to follow the default instruction. Very simple. However, there are several limitations of the student versions. The first one, you can analyze up to only 100 observations. If you have more than that, doesn't work. Second, you will not be able to save any data because it's free. The third one, you cannot save any path analysis or SEM diagram, which is very important. However, we can get around these limitations. You can use print screen button, then paste the result into MS Word file to complete your dissertations. This print screen will copy an image of the monitor to the clipboard. Then you can hit Ctrl+V to paste it into the MS Word document to be edited or cropped for professional presentations. Okay, today we will focus on diagnostic statistics, which are widely used in research. Other statistics will be discussed in my next video. We can divide it SEM reporting, structural equation modeling reporting, into two simple categories. First is outer model, measurement model. The second one is inside. Inner model or structural model. Within the measurement model, we will be discussing two statistics, factor loadings and Cronbach alpha. What are factor loadings? Factor loadings, or lambdas in the literature, demonstrate the validity of the measurement model and provide insights in the relationship between latent constructs and observed indicators or survey questions. In addition, you must align coherent reported factors loading with the theoretical framework, prior research, theory. Always go back to theories. Lambda represents the strength and direction of the relationship between the latent construct and its indicators. Lambda values range from -1 to +1, similar to correlation coefficient. Remember? -1 to +1. Higher lambda, absolute value closer to 1, indicates stronger relationship, suggesting that observed variables or indicators better represents the latent construct. And lambda closer to 1 suggests the indicator highly reflects the construct. Conversely, lambda closer to 0 indicates weak association between the indicator and the constructs. Lambdas above 0.7 are considered strong, between 0.4 and 0.7 are moderate, while below 0.4 may be considered very weak. Negative lambda signifies an inverse relationship between the indicators and the construct. However, you must always contemplate whether lambda has the correct sign, plus or minus, to follow the relevant theory literature. Incorrect sign could signal maybe there is issues with your data. This wrong sign might stem from the factors like inadequate reliability or validity, flawed data collection methods, model misspecifications, multicollinearity, or other computational errors. Based on Figure 1, here some example on how to report factor loadings in your dissertations. See the blue circle there. The substantial factor loadings of 0.0, 0.701, 0.830, etc. until 0.893 confirm the convergent validity of the measurement model, suggesting that the indicators or set of survey questionnaire Q11 to Q15 effectively measure their respective constructs. See the gray circle now. The high factor loading suggests the indicators 1, 3, 4, and 5 with how2 strongly contribute to measuring the latent constructs of brand loyalty. Hence, these substantial loadings indicate the reliability and validity of the measurement model or brand loyalty, capturing its underlying dimensions. In addition, these findings support the theoretical assumption that selected indicator effectively represent the customer satisfaction construct in line with established branding literature. Again, theory. However, indicator 2, 0.659 should be removed because of being lower than 0.7. That's why initially I told you we need to have more questions, because you may need to remove in some of the experiment. Referring to the green circle, the factor loadings for indicators 1, 2, 3, 4, 5 measuring sales success index were found to be 0.893 for indicator 1, etc. 0.701 for indicator 5. These high factor loadings affirm the strong relationship between the observed indicators and the latent construct of sales success index, suggesting their suitability in capturing the crucial aspect of sales performance. Cronbach alpha can be estimated by clicking construct on the left column screen and selecting it from the drop-down menu. Cronbach alpha is a reliability coefficient used to assess the reliability and internal consistency of a scale composed of multiple indicators measuring the same latent constructs. Higher Cronbach alpha above 0.7 indicate greater reliability and internal consistency among the survey questions in measuring the same one latent constructs, Based on figure 2, again look at the circle. I'll show you how to report Cronbach's alpha in your dissertations. The high Cronbach alpha, for example 0.854, 0.863, and 0.884, suggests strong internal consistency among the survey questions in measuring the written constructs of sales success, customer satisfaction, and brand loyalty, affirming the skill reliability. In the dissertation, this is one of the examples of how to report. In the dissertation, investigating sales success index by using partial least square structural equation modeling analysis, Cronbach's alpha for the brand loyalty skill was calculated at 0.854. This high alpha value demonstrates strong internal consistency among the indicators, supporting the skills, reliability, and measuring brand loyalty.